So let's look, but many times I may ask, okay, so I'll get a lens, I'll get a better lens. It collects a F number. What is the aperture versus F number? So this is to explain the situation. We have four systems here. Let's call first system unbalanced geometric. We have a large aperture, but we use an optics that is not as good. It doesn't collect all the Lambertian beam emitting from the micro-LED. In this case, we're not fully illuminating the aperture. We're not using the system as good as we could. We need to improve the optics. Okay, let's take an opposite situation, which is also not balanced. A very good optics. I collect all the light, perfect optics, low F number, what's called, but it's diffractive and the aperture is small. So now we are limited by the aperture. So I would call this system etendue-limited, and this system is F number limited. So it's not exactly the same when you compare F number with etendue. So this is as good as your optic could be. We cannot be any better. And to compare, this is two balanced system, which means in geometric, I have a very good optics that collects low F numbers, collect all the beams, Lambertian beams from the micro-LED into the waveguide. And if I have diffractive system, I would probably not need as good and expensive optics because the aperture is small. So I'm balancing F number with etendue. Okay, so that's for comparison between the two. Just Lumus is there, here. We're able to take large F number and project it into the large aperture. That's why our efficiency is the 9 times factor that you saw in the previous slide.